Hello. So I'm going to do another example of using our formula for the sequence of partial sums for a geometric sequence to find the sum that we have. So remember, our formula for the sequence of partial sums for a geometric sequence is a is 1 minus r to the n divided by 1 minus r. Okay, this is our formula. So now what we're going to do is I'm going to find the sum 2 plus 1 plus 1/2 plus 1/4 plus all the way up to 1 over 64. Okay, so what I'm doing in this case is I'm again dealing with a sum of numbers that seems to have a pattern between the numbers, right? Um, and we're in the geometric sequence section, so we kind of expect this to be geometric, right? So between these two, what are we doing? We are timesing by, well, we do this one divided by this one, so we're timesing by 1/2, right? To get from 2 to 1, we're timesing by a half. To get from 1 to 1/2, what are we doing? Timesing by a half, right? Then we're timesing by a half again. So this is geometric, right? Every time the individual terms here in this sum form a geometric sequence. And so we can find the equation of that sequence. Well, our equation will be a to the n equals a times r to the n minus 1. Okay. In our case, a is the first term, so in this case it's 2. And then the r is the common ratio between the terms. So 1/2 would be our common ratio. Okay, 2 times 1/2 to the n minus 1 will give us, like when n equals 1, it will give us 2. When n equals 2, it will give us 1. When n equals 3, we should get a half, and so on. Okay, this would be when n equals 4. Now we just need to figure out what n will give me this 1 over 64. Okay, so in other words, I'm wondering, when does 1 over 64, when does that equal 2 times 1/2 to the n minus 1? Okay, where does that happen? Well, we could divide by 2 on both sides to at least get rid of this part, right? So divide by 2. I would take the bottom and times by 2. Okay. So now we're just trying to figure out what n is. So to get rid of this, we have the thing we want to find is in the exponent. So what we can do is take a log of both sides, and it would be log of 1/2, or 0.5 if you prefer decimals, of 1 over 128. Okay. And then when we do log of a half over here, those cancel out and we just get n minus 1. Okay, so to solve for n, all I would have to do is add 1 to the other side. So we get 1 over 128 plus 1. This is equal to n. And so what we're going to do is just do log of 0.5, or sorry, we want to throw this in the calculator, right, to figure out what it is. So I would do ln or log base 10, right, either one works, of this 1 over 128, and then you would divide it by ln, sorry. ln of 0.5. Okay, and hopefully we'll get a nice number here. I think we will. Ln 1 divided by 128 divided by ln 0.5. What do we get? Looks like we get 7. Okay, so this is all 7, and then just plus 1 is n. So n is 8. Okay. So the place where we end off here is when n equals 8. Okay, so we're just adding up 8 numbers essentially is what we're doing, which again wouldn't be too bad with the calculator. If you started to get into the hundreds, then you'd run into some serious issues trying to do that in the calculator. So then what do I do? To find this number here, the original thing we were trying to find, I use my partial sum formula. So we're trying to find S sub 8, right? Because we're adding up 8 terms. A in my problem, that's the first term, right? So this is 2. And then times 1 minus r to the n. R in this case is 1/2. Okay. Raised to the n power, n was 8, divided by 1 minus 1/2. Okay. So, again, we've got something we could throw in the calculator. I have a feeling this is going to be kind of nasty. What is 2 to the 8th power? That's going to be big. 256. Okay. Let's do this. I'm gonna maybe erase my work right here and just finish this off. Okay. So I'm gonna take this over here and we'll finish. So this 1/2 to the 8th power, when I do 2 to the 8th power, I get 256. 1 to the 8th power is just 1. So we get 2 times 1 minus 1 over 256 divided by 1 minus 1/2 is 1/2. Okay. So 1 is 256 over 256, and then we take away 1 from that, so that's going to be 2 times 255 over 256 divided by 1/2. Okay, so when we divide by 1/2, we would flip the fraction and multiply it, so that would be the same as timesing by 2. So I'm going to take this and times it by 2. So let's see. 256 divided by 4, because we've got 2 different 2's that are going to cancel out with things on the bottom. I think that will be 255 over 256. And again, you don't really need to write the fraction for this. A decimal is fine. But I just thought I'd kind of show you how we got the fraction. So you could just throw this in the calculator right here. You just want to be really careful about parentheses, that the A will times both things in there, not just the one of them. Okay. So that is our That is finding the sum for a geometric type series that you're adding up terms and that. What we're going to do in the next video, it will be the last thing we talk about, is can you actually keep this going? Could you like never end this? Could you add up these numbers forever and actually get a number, which is kind of an interesting thing that we'll look at next. And the answer is yes, you can. So we'll look at that soon.